This is Chapter 4, Lesson 1, Part B. We are starting to graph reciprocal functions. A reciprocal function is a graph that would have a variable in the denominator. And the shape, the look of this graph is kind of similar to an exponential. It's like an L shape, but there's two portions to it. So what I'm going to have you do is copy down this page here. If you need to press pause in the video at any time to copy a graph, please do that because I'm going to go at a normal pace. And so for now, I'll just have you copy down. I'll give you about 3 minutes to do so. Sorry. If you're watching this video, you can also fast forward because for the next 2 minutes, there will be no talking. The domain is written like this, but I want to let you know that you can also write the domain as negative infinity, comma, 0. Now, 0 is not included. Union. So it doesn't hit at 0. The lines get super close, but they don't touch. And then it picks up again at 0. So I'm going to do parentheses and then positive infinity. That's another way to write the domain. The range would actually be the same, low to high. Negative infinity to 0, union, 0 to positive infinity. So a transformation of this graph would mean, like, as you can see, there's this blank space in the middle where the graph isn't touching. And there's two parts to it. I've got something in quadrant 1 and I've got something in quadrant 3. So what this is, I've got a transformation. In the denominator is where I'm going to shift a left or a right. It still is the opposite sign. The K, I am still shifting up and down. So basically this whole thing, I would like plot a couple ordered pairs, and then if I were to make a shift, it would be like the whole thing is shifting to the right and down, or to the right and up. And so I would have these, kind of like that, right? I would have, like, it would stick together. One doesn't move without the other. Just making sure we're all clear on that. So, horizontal, vertical. If A is negative, it's going to be reflected. So that means that across the x-axis, so this L shape would come down. and this L shape would come up. There's also stretches and compressions possible that would make it like the L shape would kind of get like more elongated and get the L shape could in the opposite direction become a little more inward. But we're not going to too much get into dealing with A. An asymptote. This is a new vocab word. Now in higher level math, it is possible for things to cross an asymptote. An asymptote is let's do the vocab word. An asymptote is a line the graph approaches and I'm going to say my graph doesn't cross. Now in higher level math, it's possible for these things to happen. So I don't want you to get too rigid in your thinking with asymptotes, but for our purposes in Algebra 2, the graph doesn't cross the asymptote. This is a weird word. I want you to practice it. So this P is like odd. So the word is asymptote. And so I said the P super quickly and I didn't really pronounce it that strongly. Asymptote. 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 Can you say that word? Asymptote. 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 And the P is so quick. Asymptote. Okay? Not asymptote. So, asymptote. Asymptote. All right. So this side I got to move on, guys. The right side. Here are some samples. Okay. I made my red dotted lines be the asymptote. My graphs get really close to the asymptote, but they never touch it and they don't cross it. So there is no table of values, but let me zoom in on number 1 so you can at least see the ordered pairs. Okay, I've got an ordered pair here at 0, 1, 1 comma basically like a half, -1 comma negative half comma 2, something. And then I have one here. So shifting left and right means that my asymptote changes. Yep, my asymptote is directly related to my H. My vertical, the line that goes up and down, is related to the H. My horizontal asymptote is directly related to the -5, my K. Asymptotes are like boundary lines. They tell you where the graph falls between. Okay. Then, for number 2, so did you draw the dotted line, which is the asymptote? I did it in red on my paper because I want you to know where like the zoning is, where the parameters, the boundaries are. Okay, I'm going to give you on number 2 where my A is negative. Okay, so I'm going down. Notice how on number 2 I'm moving up, class. The paper's moving up. On number 2, I've got a reflection across the x-axis. That -2 right there is a reflection across the x-axis. I'll move my hand. So my ordered pairs are shifted, but like approximately here, -2, -2, 1, -1/2, approximately, -4, 2, -5, 1, approximately, -7, like 1/2 ish. All right. So these are transformations. Left, right, up, down. Domain and range still is not including. So I've got this line. I've got a vertical line at -3. That's my asymptote. My graph is everywhere except at -3. Because as you can see, I've got this quadrant 2 graph. I should be over here. I've got this quadrant 2 graph that really gets close to -3, but it doesn't cross it. And then I've got this quadrant 4 graph down here that gets really close to -3, but it doesn't cross over. So -3 is the spot where my domain is empty because I don't go past that line. It's like an empty hole, void in my domain. Because I did not shift up or down, my range is going to be -infinity, and then here's 0. So this 0 area, no line is touching or crossing. Okay? All right, now I want to start with notes. So I'm going to take off this graphic organizer. And let's get started. Oof. All right. The parent function is y equals 1 over x. That means I have no shifts horizontal, no shifts up or down. Okay. How does the reciprocal function How does the reciprocal function relate to inverse variation? I'll just put RF just to save time. The reciprocal function is the xy values that are reciprocals. The reciprocal function is the xy values that are reciprocals so the xy values are reciprocals. They're opposite of each other. the x and y numbers themselves have a product of 1. So that's going to be like 3 times 1/3. And 1 is going to be my constant. Okay. So here's my table of values. I just told you that the x and the y values were reciprocals of each other. So instead of -3, I'm going to write as my y value the reciprocal of -3, -1/3. Because remember, the x and the y are going to multiply to be 1. So I'm sure that you can figure out what the rest of the table of values is going to be based on, so here's -1/3, -1/2, -1. So notice that these two together would make a 1 if I multiplied them. -3. 0 would be undefined. One-third is what? Tell me out loud. 3. 1/2 is what? 1 is. 2 is. 3 is. Good. The domain is going to be all real numbers. So it's written like a couple ways. I can do it like the graphic organizer did. X such that x cannot be 0. Or I can say all real numbers, like that special R, and then you put a semicolon, x is not equal to 0. And this undefined thing would be like 1/0. That's undefined. So in the domain, if I had y equals 1/0, that would be undefined. The range can be written both ways as well. All real numbers, however, y cannot be 0. And 0 equals 1/x. I can't solve that. So that's where the undefined comes in again. It's really easy to remember what the table of values is because it's just reciprocals of each other. Okay? I want to start graphing. I need to move on because I'm got to keep going. All right. This table of values up here needs to be graphed down here. I want to remind you that there are asymptotes. The horizontal asymptote, which is the y, is going to be y equals 0. And my vertical asymptote, which is x, is going to be x equals 0. I'll use a red pen again. Y equals 0. It's like this. I mean, it's on top of a black line, so it's just like, and x equals 0 is this. So it's really on top of the black line, right? You all get that? Now we're going to go ahead and graph all these ordered pairs. -3, comma, -1/3. -2, -1/2. -1, -1. -1/2, -2. So it gets super close to my red dotted line, my asymptote, but it never touches and it never crosses. And I'm just doing my best to try to like show you what that would look like. Likewise, so there's nothing at 0. 1/3 up 3. Over 1/3 up 3. Over 1/2 up 2. Over 1 up 1. Over 2 up 1/2. Over 3 up 1/3. So I'm graphing it to get really close. Right? That's what the parent function looks like. This then can be shifted. 3 to the right, 4 down, 5 up, whatever. My end behavior down below. As x approaches infinity, y is at 0. It gets super close, like it's never going to, as x goes to the right, positive infinity, y is not like up or down. It's like super close. It's basically at 0. Sometimes it's decimals, like 0.000053, but that's like 0. As x approaches negative infinity, this direction, x goes to the left, my y value is at 0. As x approaches 0, as x gets closer to 0, y goes to infinity. As x gets closer to 0, the value of the function gets larger. Okay? And then for negative values of x, so x approaching 0, y approaches negative infinity. Y values get smaller. Negative infinity. Can I turn the page? So now I'm going to give you, instead of a numerator of 1, I'm going to give you a problem, a graph, where my numerator is going to be 10. 10 divided by x. Okay. So I need to make the table of values. I'm going to pick super easy numbers. Like 10 over negative 1, 10 over 0, 10 over 1, and 10 over 10. So my x values I picked are things that are really easily divided. Notice that I didn't pick 2 or 5. I didn't pick 2 or 5 because I don't even want to get into larger numbers. Negative 1. 10 divided by negative 1. Negative 10. 0 is undefined. You can't graph it at 0. This is the first time I bet a table of values that you've seen. I'm putting in a number that you actually can't graph. Okay? If x is 1, 10 over 1, 10. If x is 10, 10 over 10, 1. Let me go through all of this. My domain is going to be all real numbers. However, X cannot be 0. And my range is going to be all real numbers. Another way of writing it, still, Y cannot be 0. If you care for what 2s and 5s might look like, I'll just tell you what the answers are. So now we need to plot all these points. Part of my graph is going to be in quadrant 1, and the other is going to be in quadrant 3. 1 and 3. So, quadrant 1 and quadrant 3. So, negative 10 would be at negative 1. Negative 2, negative 5. This is where the bend occurs. Negative 1, negative 10. So those are, I really only need 3. Don't go crazy and feel that you need more than that. This is totally good. This is where the bend occurs, at this negative 2, negative 5. So you're going to make a graph that goes like this. Like that. That's quadrant 3. Quadrant 1. 1, comma 10 and 10, comma 1. Graph those. Oh, and 5, comma 2 you could do. Okay. 1 over 1 up 10. 5, comma 2. 10, comma 1. I did not make any shifts up or down, so my horizontal and vertical asymptotes are going to be horizontal, y equals 0, vertical, x equals 0. So I'm going to draw it a little bit below, because obviously a red pen can never compete with a black pen. The intersection of my asymptotes is at the origin, 0, 0. Okay. Oh. All right. I have to begin to graph a transformation because you guys are, we need to practice it. So this 3 is horizontal, 3 to the right. This 2 is 2 up. So just so you know, my translations are going to be 3 to the right and 2 up. Plot every point of the parent function. Here it is. Like negative 3 is negative 1/3. I can't do them all. Negative 1 is negative 1. 1 is 1. 2 is 1/2. And then I'm literally going to move each point. So let me plot those. Okay. I'm plotting my parent function in pencil. So here's my parent function pencil in quadrant 3. And I'm getting this from the front page or my little mini graph I did my table of values right here. Okay. I'm not going to have you plug in numbers into this equation. What you're going to do is every single point, you're literally going to move 3 to the right, and you're going to go 2 up. So you're going to plot each point. Start obviously at, you could start here at -3, -1/3. Do you want me to zoom in? I'm going to go 3 to the right from there. 1, 2, 3, and 2 up. I'm in the middle of a box, or 1/3 of the box. It's like right there. -1, -1. I'm going to go 3 to the right. 1, 2, 3, and 2 up. I could even plot this point. 3 to the right. 1, 2, 3, 2 up. So it looks like this. Now, be careful about your crossings because my new horizontal asymptote is y = 2 and x = 3. I'll put that in a different color. Y = 2, x = 3. So I did them in green. Then I'll do my quadrant 1 graph. 3 to the right, 2 up. 1, 2, 3, 2 up. 1, 2, 3, 2 up. Well, 1, 2, 3, 2. No. 1, 2, 3, 2 up. Sorry, I was off by a little bit. It's like this. If you care, because we're running short on time, I'm going to write the table of values for this new red. I better put it in red. -2, -1.8. 0, 1.6. 2, 1. 4, 3. That's approximately, yeah, all the ones I drew. So my domain is going to be all real numbers, but x cannot be 3 and y cannot be 2. Remember, my range is the same as k. Sorry. Intersection of the asymptote is going to be at 3, 2. So you're plotting the parent function, and then you are making the transformation move. On your in your packet, the next page is going to be homework. I only want you to do the evens, please. Can you please write that on your paper? 2 through 14 even. 2 through 14 even. All right, I'm going to stop the video. Thank you very much for letting me record with you.